Good morning, students. I am going to start the class. Today class is very important, and the peer group leaders request the other members to come into the class. And now I am going to start the class. Is my voice? Is it clear? And everybody write your give your attendance. Okay. Is it clear, students? My voice and the board, is it appearing clearly? Right. Today's topic is the very important. We are going to discuss the Bohr's atomic model. Right. You listen very carefully. If you have any doubt while teaching, you can ask and you can write in the chat box. I will respond. Okay. And be quiet and listen carefully. Right. Let us just start. And that is till now. Is it clear, students? Anyone write in the chat box? Any problem? Okay. I'm going to start the class. Respond immediately. How much time I have to wait for your response? Is it clear, students? Voice and everything, is it clear? Respond immediately. How much time I have to wait for your response? Okay, good. Sitamani. I'm going to start the class. Right, listen very carefully. And it was very important topic. And it may become for the 5 marks. And previously, one time came for the 5 marks. And you listen very carefully. And the topic is very interesting and very easy. That is the first Bohr atomic model I am going to explain. Bohr model of hydrogen atom. Okay, right. Bohr model of hydrogen atom. Bohr model of hydrogen atom. Okay, this is our topic. And you listen very carefully. And everybody give the attendance. Roll numbers. Type the roll numbers. And then he gave some points. Right, Bohr postulates. We can say that the first point is that electron in an atom, electron in an atom could revolve in certain orbits. Okay, for atomic model I am going to explain, and this is for applicable for the hydrogen. It is very important for the 5 marks, and you listen very carefully. Okay, right. And electron in an atom could revolve in certain orbits, in certain stable orbits, without radiating, without emission of, energy. Okay, electron revolve in certain orbits around the nucleus, that is without emission of energy. That orbits are called as stable orbits. Electron in an atom could revolve in certain orbits without emission of energy. These orbits are called as, these orbits are the states, okay, are called as stationary orbits, are the states we can call. In this, why the electrons are revolving around the nucleus? the electrostatic force between nucleus and electron which is revolving in orbit. There is electron is a negative charge, nucleus is a positive charge because inside the nucleus protons are there. That electrostatic force between the nucleus and electrons, okay, serves as or acts as centripetal force. Okay, due to that electron will revolves in the circular path. This is the first Bohr postulate that is given by the scientist Bohr. Okay, and the next postulate is that electron revolve around the nucleus. Electron revolve around the nucleus. In those orbits for which the angular momentum is equal to the integral multiple of, okay, integral multiple of h by 2 pi. Okay, and he said that what he said in the second point, electron revolve around the nucleus in those orbits for which angular momentum is equal to the integral multiple of h by 2 pi, where h is the Planck's constant. Where h is the Planck's constant. You know that one. And what he is telling it here. For example, this is the nucleus. Okay, this is the nucleus, and electron is revolving around the nucleus in particular orbits. Now, for example, this is an electron. It is moving with some speed v. Its mass is m. It is moving in the circular path like this. Right? Its angular momentum. The radius of the orbit we can consider as the r. Okay, this is the orbit, and this center one is the nucleus, and the radius is m. Now what he is telling in the second one, angular momentum of revolving electron. What is angular momentum? Angular momentum denoted with l. L is the angular momentum. We can also write as mvr. L formula, angular momentum formula, mvr, that you learn in the 11th class system of particles and rotational motion, that is equal to nh by 2 pi, or simply mvr is equal to nh by 2 pi. This is the angular momentum. L is the angular momentum. MVR is the angular momentum, that is equal to integer multiple of h by 2 pi, where n is the integer. Integer means 1, 2, 3, and so on like this. Okay, for example, if you want to find out the angular momentum of the first orbit of electron which is in the first orbit, then you write n is 1, you have to write. Okay, and n we can also say that it is a principal quantum number, orbit number. Okay, principal quantum number we say. It's a principal quantum number. I think these Bohr postulates you also know in the chemistry, right? And any doubt, if any doubt is there, you write in the chat box. Third one is that, third postulate is that when electron jumps from higher energy state to lower energy state, when electron jumps from higher energy state to lower energy state, what happens? Energy releases, right? That released energy is equal to the difference in energies of two energy levels. Okay, when electron jumps from higher energy state to lower energy state, what happens? For example, second orbit to first orbit, if electron jumps, then what happens? The energy releases. That energy releases up, that is equal to the released energy is equal to the difference in energies of two energy levels. Every energy level and every orbit has some energy. That is equal to difference in energies of two energy levels. When electron jumps from higher energy to state to lower energy state, what happens? Okay, a photon releases, energy releases in the form of photons, right? Photon is emitted. A photon is emitted. I will continue. You take the screenshot. What you are telling it here previously, that is when electron jumps from higher energy state to lower energy state. Third point you see, when electron jumps from higher energy state to lower energy state, a photon is emitted. Photon releases, right? Photon is emitted. Then what about that photon? A photon is L is angular momentum. Priyamato, L is an angular momentum. Okay, and a photon is emitted. A photon is emitted. Its continuation I am going to explain here. A photon is emitted. A photon is emitted having continuation. This one, a photon is emitted having energy. That photon energy equal to the energy difference, energy difference between that states. Very simple. I will explain. You listen very carefully at here. Oh, this is the, for example, higher energy state, second orbit or anything. This higher energy state has the energy E2. This is the lower energy state. For example, it's any orbit you can take, either second orbit or the first orbit like this. This is something first orbit. This is the, either you take it as N1 state or it as N2 state. Okay, you take it as N2 and you can take it as N1. Now, for example, one electron goes takes the transition. Okay, this is an electron. Okay, this electron in the second orbit, N2 orbit, and it came back to the first orbit. Okay, the first orbit has energy, N1 orbit has energy E1. So when electron transition occurs from higher energy state to lower energy state, energy releases, right? The energy releases. That released energy appears in the form of photon. That means photon energy is what? H nu. Right? Energy releases it here. That released energy appears in the form of photon. That photon energy, right? When electron jumps, when transition occurs from higher energy state to lower energy state, E2 to E1, energy releases in the form of photon. That emitted photon has energy that is equal to difference in energies of two energy levels. That means E2 minus E1. And here energy released is equal to, right? Energy released, energy released, energy released. Okay, it is equal to energy of photon, right? Okay, energy released is equal to photon energy. That photon energy is equal difference in energies of two energy levels, that is E2 minus E1. Then here one thing we have to note, that what is the nu at here? Nu is the frequency of emitted radiation. During the transition, radiation will emit. When electron jumps from higher energy state to lower energy state, then energy releases, that energy releases in the form of radiation. That radiation frequency is nu. frequency of emitted radiation. Frequency of emitted radiation. Next, what is E1? E1 is the E1 is the energy of first state. Okay, energies of two states actually. E1, E2 one time we can write. Okay, E1 comma E2 are the energies of two states, right? Higher energy state and lower energy state. E1 is the energy of lower energy state. Okay, energies of two states, right? And the next topic is derivation is very important. I'm going to start now. Okay, that is radius, radius of orbit, radius of orbit, and energy of electron, energy of electron. Derivation is there. The derivation is very important. Energy of electron in certain orbit of hydrogen atom. Once read the heading, what we are going to do, right? You listen very carefully. If you have any doubt, you can write in the text box. Okay, right. What we are telling it here, the radius of orbit and energy of electron in certain orbit of hydrogen atom. What we have to first we have to find out the radius of orbit, and the next energy of electron in certain orbit also we have to find out. Then for that purpose, what we have to do it here, we can consider an electron, consider an electron of charge E. Consider an electron of charge E is revolves around the nucleus of charge plus ZE, where Z is the atomic number, in a circular orbit of radius, circular orbit of radius R. So I will explain every point. Don't worry about anything. Okay, what we are telling it here? We are writing the heading as hydrogen atom, but we will derive the for certain atom, no need of hydrogen atom. That atom has Z protons. Then Ze is the nucleus charge. This is the nucleus, and one electron is revolving around the nucleus. This is the orbit. Okay, in that orbit, electron is revolving. But difficult to draw in circle on this. Right, got it. And this is the nucleus. The nucleus charge is plus Ze, and here one electron is there. This is an electron. The electron charge is E, and electron is revolving around the nucleus, right? And the radius of the orbit we can consider as the R. This is the radius. Radius of the orbit is R, and now electron is revolving around the nucleus. If you take any atom, electron revolves around the nucleus, right? You know that one. Now, to revolve the electron in around the nucleus in the circular path, centripetal force is required. Who will provide the centripetal force? This positive charged nucleus. Nucleus has the protons and neutrons inside it. Electron revolving. Electron is the negative charge. Nucleus is positive charge. Nucleus attracts the electron towards its center. Due to this attraction force, right, it will move in the circular path. Based on the Bohr's postulates, Bohr's hydrogen atomic model, we have to derive the formula for the radius of orbit. Then in this we are considering that one electron, okay, that is revolving around the nucleus of whose charge is Ze, and in a circular orbit of radius small r. Then in this what happening? Electrostatic force between the nucleus and electron serves as centripetal force. We know that one. That means electrostatic force serves as centripetal force. This we know already. Yes or no? Electrostatic force. Electrostatic force between what and what? Nucleus and electron. Nucleus and electron serves as what? It's an attraction force. Positive and negative charged electron, positive charged nucleus attract with each other. That attraction force is the electrostatic force. That electrostatic force between the nucleus and electron act as, otherwise serves as what? Serves as centripetal force. This is according to Bohr's first postulate. First postulate. Bohr scientist gave the three postulates. In that first postulate is this one. Okay, you take the screenshot. I am going to move to a side. Let us continue. Now, what we are going to do it here? I am going to continue. Right, you listen very carefully. What we are telling it here? Electrostatic force serves as centripetal force, right? That means we write as electrostatic force. Electrostatic force. I will erase total otherwise. Right. Which force serves as centripetal force? Tell me. Electrostatic force. Electrostatic force serves as centripetal force. Right. Then we write here centripetal force is equal to electrostatic force. Centripetal force is equal to centripetal force is equal to electrostatic force. What is the centripetal force? Electron is revolving, whose mass is m. Electron is moving in the circular path. Centripetal force formula is mv square by r. Electrostatic force is the force between the nucleus and electron. That is a 1 by 4 pi epsilon naught into q1 q2 by r square. Nucleus charge is plus Ze, q2 charge is electron, electron charge is E, then by r square we have to write. There is a distance between the, this is the electrostatic force formula 1 by 4 pi epsilon q1 q2 by r square. We have to cancel this. Okay. Then we have to take r to left side. Then we will get one equation. mv square r is equal to, on the right side we will get Ze square by, derivation is very important and you listen very carefully. And if you have any doubt, you can ask me. Ze square by 4 pi epsilon naught. This is equation 1. According to Bohr's first postulate, we got this one. And next, according to Bohr's second postulate, what we write? According to Bohr's second postulate, What is the second postulate? Angular momentum. Angular momentum is capital L. If anybody moves in the circular path, it has angular momentum, right? According to the Bohr second postulate, angular momentum of revolving electron, that is equal to nh by 2 pi. This we can write as L is the angular momentum. But the angular momentum formula is MVR. MVR is equal to nh by 2 pi. We write M is the mass of the electron which is moving in the circular path. V is the speed of the electron. R is the radius of the orbit. And squaring on both sides, we can square the above equation, right? Squaring on both sides. If you square on both sides, then what you will get above equation? Then above equation we will get like this: m square into v square into r square is equal to n square h square by 4 pi square we will get, right? Okay. Now we have what we have to do it here now. We have to divide both of them. Okay. And this we can consider as equation 2. Have you understood up till equation 2? If you have any doubt, you can ask me kindly. And now what we have to do, equation 2 by equation 1 we have to calculate. When we do this one, we will get like this, right? mv square r square, m square v square r square by, we will get as mv. Oh, here I will write in the next step. Here it is somewhat difficult because the place is not sufficient. Okay. Mv square r square is the equation 2 left side. Equation 1 left side is what? Mv square r. Right side is also we have to divide. What are the right sides? Equation 2 right side is n square h square by 4 pi square. By equation 1 we have to write equation 1, but it will be reverse because it is pi, right? It will become like this: 4 pi epsilon naught by z e square, right? Next one we have to write like this. And okay, thank you Priyamato. M cancel and v square will cancel and r square will be cancelled. What's remaining on the left side and what's remaining in the right side? This square will cancel. The remaining is on the left side. Here one m will remains. Okay, one r will remains. On the right side, what will remains? N square h square epsilon naught. Okay, this 4 also will cancel with each other. N square h square by pi into pi z e square. Pi z e square. Okay, I want the radius. R is equal to, we write as n square h square epsilon naught by this m goes to right side. Then we will get as pi m z e square. This is the formula for the radius. This is the formula for the radius. This we can take as equation 3. What is this? N is what? Principal quantum number, right? N is what? Principal quantum number or the orbit number. N is the orbit number. Okay. N is the orbit number. Which orbit? Okay, radius you want to find out. H is the Planck's constant. You know very well. Okay. Right. If you will get any doubt, you can ask me. Okay. And epsilon naught is the permittivity of a free space. You know very well. No need to write this one. And m is the mass of the electron which is revolving in the circular orbit. Mass of electron, okay, which is revolving in the circular orbit. Revolving in orbit around the nucleus. And that is the atomic number. That is the atomic number. Okay, which atom you are taking? E is the charge of electron. Okay, E is the charge of electron. Charge of electron. Next, any other terms? If you want to write epsilon naught, also you can write epsilon naught is the permittivity. These are the terms which are present in the equation. Okay, permittivity of a free space. Can you tell one thing that is there any unknown term for you in this? Hmm? Right. This derivation till now, no doubt, no? You have to remember this derivation. N square h square epsilon naught by pi m z e square. Right. And next, I'm going to continue and right. You listen very carefully. Okay. All right. Oh, the thing is that previous equation we got the radius. R is what actually? R is what? R is the radius. Okay. Oh, radius of radius of nth orbit of certain atom formula is this one. Okay, certain atom, any atom you can take. Okay, which atom radius you want, that atom radius we can write as like this, that we got as formula n square h square epsilon naught by pi m z e square. That formula we got it here, and then that is the radius. R is that one. We got n square h square epsilon naught by pi m z e square. This is the formula to find out the radius of certain orbit. For example, if you write like this, h value, epsilon naught value, h is the fixed value, epsilon naught value is the fixed, h is the Planck's constant, epsilon naught is, pi, mass of electron, 9.1 10 to the power of minus 31 kg, and z we don't know, e is the electron charge we know. Then we write all the values that you know, and then you will get one formula, that is radius we will get as 0 point radius of nth orbit, r suffix n you take. Okay, r suffix n. Previously you got that formula from the equation 3 only. We are writing the same formula, right? Equation 3. Yes, from equation 3 we are writing the formula n square h square epsilon naught pi m z e square. From equation 3 we wrote here. Okay, right. And you see here, this one, h value, epsilon value, m value, z value, m value, pi value, all values you substitute, then you will get 0.53. Unknown value is n square by z, but this is angstroms. This is the formula in angstroms. This equation is the equation number 4. Okay, this will be there in angstroms. You will get the radius in angstroms. Okay, and this can be considered as the equation 4. And now this is the radius of nth orbit, of certain atom. For example, if you want to find out the radius of O, how you got 0.53? 0.53, how you got? Just use of I substituted the h square. I can write here if you want. Okay, and you see here, I will write here. What's the remaining? H square epsilon naught by pi m e square. Okay, h square epsilon naught pi m e square. H square epsilon naught in the numerator, and the denominator pi m e square. Its value is 0.53 angstroms. 0.53 angstroms. That you substituted it here. H square epsilon naught pi m e square is there. Its value is 0.53 angstroms. You substitute here 0.53 into n square by z you will get. Then radius of radius of radius of first orbit of, at this we can consider as equation 4. Radius of first orbit of hydrogen atom. Radius of first orbit of hydrogen atom is called as Bohr radius. What is Bohr radius? What is Bohr radius? Radius of first orbit of hydrogen atom. First orbit means n is equal to 1. You have to write, and hydrogen atom means you have to write z is equal to 1. First orbit n is equal to 1. Hydrogen atom atomic number 1. You substitute here. Then the radius is called as the Bohr radius. Can you tell what is the value of the Bohr radius? Can anyone write in the chat box? What is the value of Bohr radius? From equation 4, you substitute all values, you will get 0.53 into 1 square by 1. What you are getting here? 0.53 angstroms. It is what? Radius of first orbit of hydrogen atom. Radius of first orbit of hydrogen atom is 0.53 angstroms. That means that is only called as the Bohr radius. The Bohr radius value is how much? 0.53 angstroms. 0.53 angstroms. This is the Bohr radius. By using this formula equation 4, right? Aditi and Priyamato gave the answer, right? By using this formula equation 4, you can find out the radius of any orbit in any atom. For example, you want the radius of second orbit in helium atom. N equal to, you write 2 because second orbit helium atom atomic number is 2. Is it right? Then do we have to write? Then we have to find out the radius. And we can also find out the radius of sodium in the third orbit. What is the radius of third orbit of sodium? Third orbit means N is equal to 3. You should write sodium. What is the atomic number of the sodium? Anyone can write? Can anyone? No one. Is it 11? Now, this is about Bohr radius. Okay. In the heading, what we wrote? Radius of the orbit we have to derive. We derive the radius of orbit. Okay. Next, what we have to derive? Next, what we have to derive? We have to derive the energy of electron. Energy of electron we have to derive. For that, we have to find out the kinetic energy and the next potential energy, right? Next total energy. Kinetic energy of electron in atom we want to find out. Kinetic energy of electron. That we already previously also we find out the kinetic energy, right? And the same thing we can do it here, right? Again, the centripetal force will serve as electrostatic force. Based on this, we can find out the kinetic energy of electron and the centripetal force, kinetic energy of electron in atom in orbit. Is it right? Kinetic energy of electron in orbit we have to find out. Kinetic energy of electron in the last class also we derived, right? The same format it will be there. And centripetal force serves as, which one serves as centripetal force? Electrostatic force. Very interesting topic and you listen very carefully. Only more one lecture required to complete this chapter. mv square by r is equal to electrostatic force already we derived, right? Electrostatic force between the nucleus charge is plus Ze, and the electron charge which is revolving in a particular orbit is E, right? Like this. Oh, we now I'm not got the circle. Different shape we got. We already drawn the diagram, no need to draw again. At 1 by 4 pi epsilon naught into Q1 Q2 by R square. Q1 is the nucleus charge, Q2 is the electron charge by R square. We have to simplify it. Then R square will cancel. Then we will get mv square. mv square is equal to, we will get as Ze square by 4 pi epsilon naught R we will get. Okay, right. And now I want the kinetic energy. Here mv square, m is the mass of the electron, v is the speed of the electron. And mv square we got. I want the kinetic energy. Just you multiply with half on both sides. Right. Let us see here. This force is belongs to last one. Okay. Otherwise we erase this. Right. Now let us continue. What we are telling it here. Previous equation is what? mv square we got, right? Multiply above equation with 1 by 2 on both sides. Multiply above equation above equation with 1 by 2 on both sides. With 1 by 2 on both sides. Then what you will get? We will get as half mv square. Right side, what is there? Right side, we have to watch it. Z square by 4 pi epsilon naught r. It will become you when you multiply with half on both sides, it will become Z square by 8 pi epsilon naught r. This is the kinetic energy. We got the formula for the kinetic energy. That is Z square by 8 pi epsilon naught r. This is the formula for the kinetic energy, equation 5. We got the kinetic energy. Next, I want to derive the formula for the potential energy. Right, potential energy of electron. Okay, potential energy of electron. How we will get the potential energy? Right, it was very simple. That is potential energy formula we know already. That is potential energy formula is what? 1 by 4 pi epsilon naught into Q1 Q2 by R. This is the formula for the potential energy. Here there is one atom and there is one electron. Electron is revolving around the atom, around the nucleus in the atom. This is the nucleus, okay, and nucleus charge is plus ZE. This is an electron revolving around the nucleus. This electron has potential energy. The potential energy formula is 1 by 4 pi epsilon Q1 Q2 by R. And here we have to write the potential energy is equal to 1 by 4 pi epsilon naught Q1 Q2. Q1 is the nucleus charge, that is plus ZE, and Q2 is the electron charge E, by separation between them is R. This is the formula for the potential energy. But one thing, potential energy must be negative. That's why we have to take it as minus E. Then finally we got the formula for the potential energy. That is the potential energy we got as minus ZE square by 4 pi epsilon naught R. This is equation 6. We got the potential energy. And the next I want the total energy of electron in hydrogen atom. Total energy of electron in certain atom. Total energy of electron in certain orbit of hydrogen atom. How to find out? Total energy means this total energy, just we have to add both the energies. Okay, the total energy is the sum of kinetic energy and potential energy, or the potential energy and kinetic energy. Both we have to add now. That we will get as ZE square by 8 pi epsilon naught R from the equation 5 plus minus ZE square by 4 pi epsilon naught R. Okay, potential energy is minus is there. That's why we got here minus. The next we have to simplify it here, the total energy. Then we have to common the Z square by 4 pi epsilon naught R. Then when you common it, we will get here 1 by 2. Or otherwise else you can also do the LCM. Anything you can do. Okay. In any way you can simplify. Okay. 1 by 2 minus 1 remains. Or otherwise you can do the LCM. In any way you can do. Whichever you like, that you can do. Any method, final answer gives the same. That is, the LCM is 8 pi epsilon naught R. In the numerator, you will get Z e square minus 2 Z e square we will get after the LCM. Then finally, what you will get the total energy? Total energy we will get as minus Z e square by 8 pi epsilon naught R we will get. 8 pi epsilon naught R we will get. And here we have to write the radius formula from equation, I think it is minus ZE square by 8 pi epsilon naught. Previously radius equation we derived, right? I'm not remembered the equation number. I think it will be 3. Once go we can go and watch it. What is that? This is equation 3, right? And from equation 3 we write the formula here. Okay, you know equation 3, that we have to write it here. Mhm. Right, R is what? R formula is what? N square H square epsilon naught by pi m z e square. Pi m z e square. This is from equation 3. You see the equation 3. Equation 3 we derived for the radius. Right now we have to simplify it. Pi will cancel. Next, this mz e square goes to numerator. Then m into this z square e square e power 4. And the next n square h square epsilon naught square. Right. The next equation you will get like this. It was very interesting topic. Let us go for the continuation. You see, this is the something is appearing in the last derivation part, or you neglect it. I will draw the lines because actually the derivation part is linked with the previous one. That's why I am not deleting. Now you see. Oh, okay. Let us continue now. What you got in the previous equation? Can you tell? Can you simplify it? It was very difficult. No? With pen paper, we have to do. What you will get in the next step? Oh, I also look at the next equation is total energy. That is the energy equation is we will get as minus m z square e power 4 by 8 n square h square epsilon naught square. This is the final equation of the total energy, right? This is equation number. Previously, at what equation we are there? From this step, from the last step, okay, m goes to numerator, m, z goes to numerator, z square, e power 4, e square also goes to numerator, e square into e square, e power 4. We are getting in the m z square, e power 4. In the denominator here, 8, n square, h square, this epsilon into epsilon naught square we are getting. Right? No problem. No? Okay. We want the equation numbers also. Last equation number is 6. Right now, this is the 7. This is the 7. Equation number 7. Nice. Now let us see. Next. In this, what are the terms? The terms you know that what is E in this? E is the energy of electron in certain orbit. Okay. For example, we can write like this. There is some value is there here. We can do like this. In this there is some term is that this I will modify like this, minus m e square, oh, power 4, minus m e power 4 by 8 h square epsilon naught square into what's remaining, z square by n square we will get. Okay, but one thing is that m e power 4 by 8 h square epsilon naught square value is equal to rch. R is the Redberg constant, C is the speed of light, H is the Planck's constant. Its value is 13.6 electron volts. This you substitute in above equation. Then you will get as minus 13.6 Z square by N square electron volts you will get. This is the formula that is used to find the energy of electron in certain orbit. Okay, and that is in electron volts. In electron volts, E is what here? E is the energy of electron. Energy of electron, E suffix n also we can write. Energy of electron in nth orbit of certain atom. Nth orbit of certain atom. Actually, we want to find out the energy of hydrogen atom. In case of hydrogen atom, what happens? In case of hydrogen atom, what condition we have to write? Very simple. Okay. In case of hydrogen atom, we have to write like this. That is, Z is equal to 1, we have to write. Very simple. Then you will get energy as minus from equation 7. Okay, Z is equal to 1, you have to write. From equation 7, we will get like this. From equation 7, we will get as E is equal to minus m e power 4 by 8 n square h square epsilon naught square we write. Okay, and from equation 8 what we will get? From equation 8 what we will get? From equation 8 we will get as like this. E is equal to, we will get as minus 13.6 by, this one is z is 1 square by n square. Then we will get as minus 13.6 by n square. 13.6 by n square electron volts. Okay, this is for hydrogen atom. We derived the energies, right? And what is R in above equation? Here we know one thing that we write in the note. Okay, this is completed. Total energy of electron is negative. What it indicates? Total energy of electron. Essay is completed. 5 marks question. Very lengthy. Total energy of electron is negative. Means electron bound by the nucleus. Okay, right. This is the thing. Till now we discussed the many things. Okay. Very good. Nice. How it is? What about the topic? Can you comment? How is today class? Write in the comment box. Are you enjoying? Note. Okay. What you got the energy of electron? Energy of electron we got is energy of electron in nth orbit of certain atom. Nth orbit of certain atom. And the energy of electron in nth orbit of certain atom formula what you got here, very lengthy big formula you got here. M, what is that? Mz square e power 4 by 8 n square h square epsilon naught square. You got this formula. In this what you got here, this if you will change like this also you got minus 13.6 into z square by n square electron volt, this one, right? That also you got. In this what I said that, but I said one thing that m e power 4 by 8 h square epsilon naught square. This I wrote like this, minus m e power 4 by 8 h square epsilon naught square. The remaining is z square by n square. Then this one we write as RCH is equal to RCH. We take this CH to left side, then you will get the R formula. Okay, RCH it is. Then R is equal to what you will get from this. R is m e power 4 by 8. We have to take C to left side and H to left side. 8 h cube epsilon naught square into C. This R is called as the Redberg constant. Have you heard the Redberg constant? Redberg constant. The R value, if you substitute all values of that one, you will get the R value, and R value you will get is 1.097. If you substitute the M value, E value, and H value, epsilon value, C value, C is the speed of light, E is the electron charge, M is the mass of electron, H is the Planck's constant, all you substitute. You will get the 1.097 into 10 to the power of 7 meter inverse. Meter inverse. This is the Redberg constant value. If you substitute this one in above equation, what you will get? Okay, from above equations, we write like this. That is energy of electron. We write as like this. You see here, m e power 4 by 8 h square epsilon square is there. This we write RCH. Then energy formula we write as minus RCH into z square by n square. Okay, where R is what? C is what? This is another formula. Okay, that we derived. R is the Redberg constant. In chemistry, you studied, I think. Redberg constant, that is a constant. C is the speed of light. Speed of light. Its value is 3 into 10 to the power of 8 meter per second. And Z is the atomic number. Z is the atomic number. N is the principal quantum number. N is the orbit number. Okay, we can also write it as orbit number. First orbit, second orbit, like that. That is the atomic number. N is the orbit number. RCH is the Planck's constant. You know all values. What is the value of the Planck's constant? Planck's constant value is 6.626 into 10 to the power of minus 34 joule second. Right? Okay. Can I continue, students? And based on your suggestion, if you tell, I will continue for more 15 minutes. Otherwise, we will close. Are you interested? Can I continue or the close? Okay, more 10 minutes I will continue. Frequency and wavelength of emitted radiation. Emitted radiation during transition of electrons. Transition of electron. Okay, and listen it here. Only 10 minutes I will continue. Exactly 10 minutes. Don't worry. I will close. Right. This is the first energy state. Okay, first energy state. This is the initial energy state. Its energy state number is Ni. This is the final energy state Nf. Its energy is E1. Its energy is E2. Just it is a orbit. It is a orbit. We are taking orbit like energy state. And this and every energy state has some. In every energy state, electron has some energy. Okay, energy of electron we derived previously. For example, the electron is jumping from the this state to this state. At that moment, what happens? Energy releases. That released energy, that released energy frequency, that released energy frequency formula, and that released energy wavelength formula we are going to derive. Then further purpose, released energy formula is what? Then further we know that mm, when electron jumps from higher energy state to lower energy state, the energy releases in the form of photon. Energy of electron in photon orbit. What is that? Energy of electron in certain orbit formula. In certain orbit formula is what? Yes, just now we derived that we will use in the note we derived, that is minus RCH into Z square by N square. This is the formula. Okay, and then I want the this is the initial state where the electron initially it is present, and this is the final state, right? Electron starts from initial state. Initial state we can take as Ni, and final state we have to take as Nf. Initially this we have to take as Ni, and this we have to take as Nf, because this is the final energy state. Okay, and now energy of electron in initial state we have to write energy of electron. Energy of electron in initial state. Can you tell? Energy of electron in initial state is what? E2, that we write like this, minus RCH into Z square by, we write as Ni square, we write. Initial energy state is Ni. Okay, and then final energy state. Energy of electron in the final state, final orbit. Energy of electron in the final state. Energy of electron. Energy of electron in final state. That means initially it is starting from here and going to here. This is the electron, right? Electron moves like this. Then final state. What is the energy in the final state? That is the E1 from the figure. That we write as minus RCH from the figure. Z square by final is NF. NF square we have to write. Okay. And when the electron jumps from here to here, what happens? Energy releases, right? The released energy during transition of electron. Okay, during transition of electron from Ni to Nf. Okay, initial energy state Ni, final energy state Nf. Energy releases. Energy releases. What is the released energy? Released energy formula, you know, that releases in the form of photon, and that is equal to difference in frequencies of two energy levels, right? That is we know, that is E is equal to energy releases, that is equal to H nu, that is equal to E2 minus E1. Is it understood? Have you understood? Till now I continued for only 3 minutes. Next hour 7 minutes only. Okay. Don't take tense, right? Don't feel difficulty. Try to continue in the class. Next. Nice. Then energy released E is equal to, we got H nu. energy released is the E is equal to h nu. Okay, on the right side, what you got? The right side is what you see. The right side, what is what? E2 minus E1. E2 formula is what? Can you tell E2 formula from equation 2? E2 minus E1, na? H nu equal to E2 minus E1. Okay, H nu is equal to E2 minus E1. E2 is what? E2 is minus RCH Z2 square by Ni square minus E1. E1 is what? Minus RCH Z square by NF square. Is that right? Okay. Now we have to simplify it. H nu is equal to, then right side we have to simplify. Minus RCH Z square by Ni square plus RCH Z square by NF square. Now RCH is common. Then when you will common the RCH Z square, you will get 1 by NF square minus 1 by Ni square plus 1 by NF square we will get. Next, H nu is equal to, we will get as RCH into Z square. We write as 1 by NF square minus 1 by Ni square we write. Okay, this is H nu is the energy released, na? Energy released formula, this one. Okay, but we write here nu as C by lambda. Nu is C by lambda. Hc by lambda. I want the frequency, na? Actually, why from so many steps onwards we are continuing the H it here. We common the H it here, we can cancel it. Is it right? On the left side H nu is there. On the left side H nu is there. That we have to cancel H, and here we should not write H. Is it right? Nu is equal to, we write as RC Z square. This formula we write. This is the frequency of emitted radiation. Okay. Frequency of emitted radiation is this one. Nu is equal to RZ square. RC Z square into 1 by NF square minus 1 by Ni square. This is equation 3. This is the frequency of emitted radiation. Okay. And if you want to substitute, but you know nu is equal to C by lambda. But nu is equal to C by lambda. More 5 minutes. Then we have substituted here. C by lambda is equal to, we'll get is RC Z square into 1 by NF square minus 1 by Ni square. Okay. CC also gets cancelled. What you will get the 1 by lambda? 1 by lambda we will get is RZ square into 1 by NF square minus 1 by Ni square we write. Here we write, but we know, but in case of, this is the wavelength formula. To find out the wavelength, we will use this. Right, lambda is the emitted wavelength radiation. Okay, this is equation 4. But in case of hydrogen atom, what we write? Z is equal to 1 we write. Then what you will get? 1 by lambda is equal to R into 1 by NF square minus 1 by Ni square. Is it okay? Have you seen this formula in anywhere? When electron jumps from higher energy state to lower energy state, what is R at here? R is the Redberg constant. R is the Redberg constant. By using this formula, we can find out the wavelength of emitted radiation during transition of electron from higher energy state to lower energy state. Redberg constant. Ni is the, what is the value of this one? 1.097 into 10 to the power of 7 meter inverse. Next, Ni is the initial energy state. initial energy state, and NF is the final energy state. Okay, what is our heading? Our heading is the frequency and wavelength of emitted radiation during transition of electron from higher energy state to lower energy state. We derived the both formulas. This is the formula for the frequency, and this is the equation 3 for formula for the frequency, and equation 4 is are the 5 are the formulas for the wavelength of emitted radiation. Okay, right. Okay, more time completed. Thank you to all. And I took only 1 hour 10 minutes. Okay, not much more than earlier. Okay, thank you to all. And remaining we will discuss tomorrow. And more 1 or 2 lectures required to complete this chapter. Okay, to complete the total syllabus, only more 5 6 hours required. 5 6 hours. Okay, be patient and come to the class. Okay, thank you to all. And I'm going to close the meeting. If you have any doubt, you can write in the chat box. And